All right, well, hello AP Physics students and welcome to this video lecture. It's going to be all about friction. Now, we've talked a little bit about friction. We know that friction is a force which opposes an object's motion, but I want to get deeper into friction and what that actually, and the different types of friction that we could possibly have. So the first type that we could have is called static friction. Now, this is a type of friction which quote unquote prevents an object from moving. Now, I put prevents in quotes because we have to be a little bit careful when we talk about static friction. Static friction is not present between two objects unless there's an applied force. Okay, so, let's say that I have a block just resting on some surface. Well, there's no static friction here because there's no applied force. But as soon as we apply a little bit of force, we now have some static friction there, okay? Now, the big thing with static friction is that we can apply a little bit more force to this scenario here. We can apply a little bit more force, and we have a little bit more static friction, okay, and I'm just going to abbreviate that FS. And we overcome static friction by applying enough force to counteract what we call static friction max, okay? And this static friction maximum is equal to this thing called the coefficient of static friction times the normal force. So as soon as we get just a little bit greater than what this maximum static friction is, then this block will begin moving. Then our forces are now unbalanced. Now you may be wondering, what is this coefficient of friction? Okay, what does that coefficient of friction actually mean? Well, the coefficient of friction is simply a ratio between maximum static friction and our normal force. So we could write out a little expression for that. So we could say that static friction is equal to Fs max divided by our normal force. Okay, so that's really what our coefficient of static friction is. Now, big takeaway here is, again, this block here is going to start moving when we just slightly overcome this, this maximum static friction. So what we could say here then is that if our maximum static friction is equal to our applied force, we have no motion. However, if I'm going to have to write small here. If Fs max ever becomes less than force applied, then we do have motion. Now, our second type of friction is kinetic friction. And kinetic friction, well, kinetic means motion. So what kinetic friction is it's our frictional force which opposes sliding motion between two objects. Now, we have an equation for this. We can say that Fk is equal to our coefficient of kinetic friction, and that's multiplied by, again, our normal force. Now, I think it's really important to note that these coefficients for static friction and kinetic friction are typically different. And typically, our coefficient of static friction is greater than our coefficient of kinetic friction. Now, another really important thing to know with these coefficients of friction is that they're dependent on the materials that we're working with. Okay, so what are those objects actually made of? So, for example, let's say we had ice sliding on ice. I don't know why that would ever happen, but let's say we have ice on ice. Well, the coefficient of static friction between those two materials is 0.1, but the coefficient of kinetic friction is 0.02. Now, let's just do another example just to show you that it's dependent on the materials. Let's say we had glass on glass. Okay, again, I don't know when that would happen, but here we go. So glass on glass, the coefficient of static friction is 0.94, but the coefficient of kinetic friction is 0.4. So again, notice that our coefficient of static friction is typically greater than our coefficient of kinetic friction. And I just want you to think about this from maybe past experiences. Let's say that you're trying to push a big heavy box. Well, it typically takes more effort for you to get that box moving than it does to keep that box moving. And that is because of these different coefficients of friction, okay? Static friction is, coefficient of static friction is greater, therefore it takes a little more effort to get it moving than it does to keep it moving, because our coefficient of static friction is less. All right, so now I just want to do a little bit of application with this idea of friction. So in this scenario, we have a skier who is holding onto a tow rope, and we want to figure out what is the magnitude of the maximum force that the tow rope can apply to the skier without causing her to move. So this problem should tip you off that we're in equilibrium, so we're going to have to be using some equilibrium equation. Now, again, good practice here. We're always going to draw our free body diagram. Okay, so I'm going to draw my free body diagram here. We have the force of gravity acting on that skier. We have the subsequent normal force. We have some force of tension from that rope. And then we're going to have some sort of static friction there, okay? So what we need to do is we need to write out our equilibrium equations. Ultimately, we're trying to find this force of tension here. However, if we think back to what our equation for static friction is, well, we know that static friction max is equal to the coefficient of static friction times our normal force. So what we first need to do here is figure out what our normal force is. And we can very easily do that by utilizing an equilibrium equation in our y direction. So summation of forces in our y direction, those are going to be equal to 0. We have our normal force, and that's going to be added to our force due to gravity. And again, that's going to be equal to 0. So extending this out, again, we don't know what our normal force is. That's what we're trying to find. If we calculate out what this skier's force due to gravity is, we are going to get a value of negative 500, and I'm just going to round this up for our purposes. So then we're going to get a normal force equal to 580 newtons. Okay, so now that we know our normal force, we can figure out what our static friction is, what that maximum static friction is. So Fs max is going to be equal to 0.14 times that 580 newtons, because that was our normal force. And we are going to get a value here of, I believe, it's going to be 81 newtons. Okay. So now we can finish this problem up, and I'm going to write an equilibrium equation for my x direction. So I have Ft, and that's going to be plus Fs, and that's equal to 0. Plug in what we know, and we are going to get a force of tension equal to 81 newtons. Okay? So there is a quick application of friction. We're obviously going to do problems that are a little bit more in depth with friction, and they're not always just going to be equilibrium problems. We could be dealing with kinetic friction as well, dealing with problems where we have acceleration. So I hope you took good notes. Please write down any questions that you may have that we can then cover in class tomorrow. So take care, AP Physics students.